So they're the pieces of equipment, and we will look at all of those in detail, and I'll show you how to use them. Do you guys use test equipment at the moment, or what do you use?
Network setting.
You just use network cellular line. Okay, very good. So how do you determine where to point the outdoor antenna? Do you use? Is there a website that shows you where
Yes.
for which country? For Luxembourg.
Yes.
So that's useful. That's very good. Okay, that actually is that's one of the things you're going to use, a website that tells you that. The other thing, you can use your eyes, a pair of binoculars. You can actually say, oh, I see the base station.
Yes.
Okay, very good. That works. And the third thing is the signal analyzer. Those three things you use. Okay, so you're using two. You just need the third. With the third, basically, you can be absolutely certain that it's correct. Okay, because I'll tell you what you can't see. When you put that antenna on the roof, you don't know if one operator is much stronger than the other operator. Because if you've got one operator much stronger than the other operator, the repeater system is going to look at this strong signal from the strong operator, and it's going to wind its power down like that. It's going to say it's too much power from Post Mobile, for example. It's going to wind its power down like that. And here's the other operator. What's the other? Orange. Orange. So here's Orange. Here's Post Mobile, and Post Mobile is strong like that. And the repeater says, okay, too much power for Post Mobile, wind it down. But look what it's done to Orange. Zero. It's zeroed out Orange. So although Post Mobile is now okay, Orange is zero. You just killed an operator. So you don't have that information in the roof. However, this will tell you that information. Okay? So your objective on the roof is to balance the signals from all operators, so you don't end up with a situation like that. So frequency bands and bandwidth. Okay, we already said the base station will always tell your phone to connect to the highest frequency. Okay, so as I said already, we're on 1800 in this room, it'll stay on that. Okay, because there's more bandwidth at the top frequencies.
When do you find if you got an operator who comes in very strong and are very low?
Yeah.
When do you define
The level.
the level? Yeah. Where?
Yeah. You need to use it. You can move the antenna.
The antenna?
You can move it this way,
Yeah.
or you could place it on the roof in a location where it's not difficult doing this with this equipment. This is not difficult. Okay, it's very, very clear. I'll show you this. We'll do a demonstration. Okay, so again, it's just I'm explaining how the operators view the services and the frequencies. So, and the operators will always try to push your phone onto 4G if it exists. If there's no 4G, it'll push it onto 3G if it exists. If it doesn't exist, it uses GSM. No GSM, no signal. Okay, so that's the preference. The operators do that. Okay, so as I said, there's two types of installations. There's the countryside. In the countryside, easy installation, more coverage, less antennas, and the outdoor antenna placement is relatively easy to do. The big city, more difficult, less coverage, you need more antennas, and it's a bit more difficult, that outside antenna. Now, again, so now we're going to dig into some technical stuff here with the cables. So we deal with SD400 cable. The rules with this SD400 cable is at 900 megahertz, let's say you're measuring 900 megahertz with your spectrum analyzer, the loss is 0.1 dBs per meter. So if you've got 30 meters of cable, 3 dB loss at 900 megahertz. At 2100 megahertz, the loss is twice. As you increase the frequency, the attenuation is more. Well, what does this mean? It means that it's more difficult to get the higher frequencies to travel through the cable and through the repeater system. Okay, so if you're designing a system that requires 2100 megahertz and 2600 megahertz, which is going to be the majority of the systems, right? You need to plan for those frequencies. Obviously, look, double the loss at those higher frequencies. Okay. So if you have an absolute power coming in at minus 70 dBms, you're looking at your spectrum analyzer and you're looking at the level, and it's minus 70 dBms, and then you take a note of that on a piece of paper, then run your cable, and then connect your spectrum analyzer into the same piece of cable 30 meters, you're going to see a drop to minus 76 dBms. Okay? If that was greater, let's say that was minus 90 dBms, you know there's a problem with the cable. You know there's a problem with the connector. Now, the reason I'm explaining all this is so you can find faults in the cable. In almost every single time me and my brother go to check out jobs that have problems, almost every single time there's a problem with the cable, there's a problem with the connector. The connector's done is incorrectly. There's a 20 dB loss in the cable. The antenna's not working. It's tricky installing those connectors, and many times we see errors. And it's such an important thing to test the cables. So when you finalize your installation, those cables need to be tested. Now, this is complicated, a bit complicated doing it this way. So Stella Radis, we're producing tools to make this easy. Right? Here's one. So this is a tone generator. Okay, this basically you plug it into the cable. So we could plug it in here, and we can do this demonstration if we have time later. And you plug it in here, okay, and it generates a tone at 2 gigahertz. Simple, just a tone. And the tone is a power, right? So basically what I would do is, first of all, I would get a piece of cable, plug it here, measure the power. Let's say it's minus 10 dBms, okay? It is typically that anyway, okay? So now I've calibrated it. I know what that is. And now what I do is I go to every cable in my installation. I put this on one end, and I put my tester at the other end, and I just test the cables. And I know what it should be for that length of cable. Okay? And I will show you this in action, okay? Not now, later. Okay, so you can see that. And once you've tested all your cables, now you know there's no problem with your cables. And all your connectors are tested and all your cables are good. So let's just look at a system. Here's a system, the external antenna, 30 meters of cable, the repeater, another piece of cable in the inside antenna. So if we wanted to measure the loss from here to here over 30 meters, let's say we're talking about 2100 megahertz, I'm measuring 2100 megahertz, I just multiply 30 meters by 0.2. What do I get? 6 dB loss. Okay, so at 2100 megahertz we get 6 dB loss here, and then we're going to also, that's approximately 30 meters, we get 6 dB loss here. If you get more than 6 dB loss, there's a problem with the cable. Here's another system. This particular system uses a big parabolic dish. We've got a lot of power here. We can afford to use a big piece of cable. Okay, it's a 70 meter piece of cable. We know our loss is 0.2 dB, just using 2100 megahertz as an example. So we just multiply 0.2 by 70, and I think it works out at 14 dBs. So that will be 14 dB loss there. If it's 20 dBs, it's a problem with the cable. Same thing. Again, we can measure our loss across that cable as well. It's going to be 6 dBs because you multiply 30 by 0.2. So at 2100 megahertz, it's 6 dB loss. Here's a practical system. So we're on the roof. We measure 80 dBms here. We're talking about 2100 megahertz again. And what happens is you've got your signal power here. 70 meters of cable, the signal's dropping. Loss. We lose 14 dBs across that piece of cable. We're down to minus 94 at this point. We put in a repeater. It gives us a bump of 60 dBs. So we've lost our signal. We hit the repeater, bump, up, like that. At the outside, we're minus 34 now, where we've bumped the signal up here. Another piece of cable, drop, down to the antenna, we're minus 40. So that's basically how a repeater system works with the signal powers and the cables. You may not have to take all this in, you know. The key point here is just to test the cables. And we're introducing tools to make that easy. Any questions about this?
So it's not only a repeater, it's also it boosts the signal?
It is basically boosting the signal. It's adding amplification to the system.
Absolutely.
It's compensating for all this loss. That's what a repeater system is doing. What it's doing is, it says, this is the signal on the roof. My job as a repeater is to get that signal on the roof and evenly distribute it throughout the building. Alright?
Well, if we lost the cable, you will get back from repeater.
Exactly. So it's compensation for all this loss. Alright? Yeah. So things that affect the signal, the distance the signal will travel from the indoor antenna, the frequency. The lower frequencies travel farther than the higher frequencies. So 800 megahertz and 900 megahertz are great. They're wonderful frequencies. You travel through many rooms. The tricky ones are the higher frequencies. The strength of the signal, the stronger the outdoor signal, the farther the signal will travel indoors. So we want the best quality signal outdoors. Very important. And then finally, are we in the countryside or the big city? The countryside signals will travel further than the big city. Why? Because in the countryside the signals are clean. It's a clean environment. There's not many signals around there. In the city, it's noisy, polluted. Okay? So you're dealing with a lot of noise and you're trying to pull out your signal from all this noise. And the effect of that is to reduce the propagation from the signal inside. And it's more difficult, basically.